Hi everyone. Sorry for the wait. My name is Colin. I'm an application engineer at Solomon, based in Los Angeles, California. Today, I'll be introducing AccuPick, particularly unknown with our newest vision control gripper. A little bit of background of our company. We have 50 years of corporate experience. We're one of the top 200 tech companies in Taiwan, also listed in the Taiwanese stock market as well. We have several business units. The business that we're in is vision systems. We have offices throughout the world. We have headquarters at 10 offices in Taiwan. We have 8 offices in China. We currently have Los Angeles and Detroit offices in US and 3 offices in Thailand and Vietnam. So this is our product line. This is our most popular our products. AccuPick will be AccuPick is a software for piece picking purposes. Soul Motion will be is the software for AI robot motion, and Soul Vision will be AI-based inspection, 2D particular. Soul Scan is our 3D scanner hardware. It uses a structured light technology to generate a pick position, 3D pick position. Now here is a major robot brands that you can easily recognize. We're easily able to connect them, us being the master. If your robot or the robot that you're using is not on this list, we can connect them by TCP/IP protocol. And we can connect to several different cameras besides our Solomon structured light scan. We can also connect to Intel RealSense and Microsoft Connect. And we can also communicate with these brands' PLCs. So since unknown is very beneficial to logistics and fulfillment centers, so we have this generic warehouse layout to demonstrate where our system could be used effectively. Staging area could be used with our system for depalletizing and palletizing. The shipping area could be used with our system for bin picking, or you have items coming in conveyor, we can pick them as well and place them into shipments. So here I have a video. So Depalletizer. So we don't have to. So unknown is a tool that can be used without any learning. So this is it's a little bit different from machine learning, because we're not teaching. We're not actually teaching. We're just using a data set that we have created in-house. So even if the boxes are packed closely, stacked very closely, we can easily differentiate the boxes and pick them accurately, as you can see in this video. So it's using a Microsoft Connect. The working distance should be anywhere from 1 meter to 2 meters. We can work up to 2 meters without losing accuracy. So it's just going to keep playing here until it's done picking. So on this next slide is an example of how these boxes are closely stacked and right next to each other. Other softwares, they tend to have trouble recognizing these 3 boxes as individual. They will instead recognize these 3 boxes as one item. And here you can see in our user interface of AccuPick. You can see in 2D that all the objects are recognized. And here you can see the pick point is generated in our point cloud, 3D point cloud. Here is another example of our user interface. This one is for motion planning. This system is used for avoiding bin collision. So we do have a basic collision avoidance that would just eliminate any items that would have a chance to collide with the bin. But this one, motion plan, it will simulate a position where it will try to pick without colliding with the bin. Here is an example of a Depalletizer. So it's a pharmaceutical market. This item is very fragile, so we need to really be careful. And it's somewhat transparent, and we're still able to recognize them individually without issue. I believe the camera will be on top here. Okay. So there is another video. So you can see that boxes are stacked very close to each other, and we can still pick them accurately. This is using our Solomon structured light scanner. The difference between the structured light scanner and Intel RealSense and Microsoft Connect is that the Solomon scanner is more accurate, but scanning time takes a little bit longer. I believe it's about 0.8 to 1.3 seconds for processing the image and generating pick position. And for Intel RealSense and Microsoft Connect, they're less accurate, but their scanning time and processing the image and generating point position is faster, about, I'll say 0.5 to 0.8 seconds. Here, you can see here, we can also pick items that are softly wrapped. So we don't have to necessarily only pick boxes. Like a lot of these fulfillment centers, logistics have these softly wrapped SKUs. We can still recognize them and generate pick position. Also for working distance, Solomon scanner also can work up to 2 meters without losing accuracy. We can go up even higher. Only is that we will lose a little bit, we will sacrifice a little bit of accuracy. So in this video, I'm going to be introducing our vision control gripper. So it's going to use a Kinect camera, and it's going to use UR Robot and our newest product, vision control gripper. Of course, using Unknown. This was done by our Taiwan headquarters for demo purposes. So here you can see the Microsoft Connect at the top. So what vision control gripper is, so based on the picking dimension, it will decide to use whether 1 tool or 2 tools or 3 tools. You'll be able to see in a moment here. So for these ones, dimension is small enough to just use 1 gripper, 1 vacuum cup. In this next video, it will show the bigger bigger item that has a bigger picking dimension. We're also showcasing that we can pick them separately. So here it's going to use 2 vacuum cups. Yeah, this one 3. So we set how much the width and height parameters within our software, and the AI will determine whether the dimensions fall within the 1 gripper or 2 gripper or 3 grippers. Now also using 2 cups there. Okay, move on to next video. So we can have so most of the times we have our camera stationary, it's mounted on a camera stand. We can also do is we can mount the camera on the robot arm. So this way, if you have multiple bins, we can still use 1 camera to do a project. So here is a project done by Chicago Electric. It's using Intel RealSense. Intel RealSense has a smaller working distance than the Solomon scan, Structured Light Scan, and Microsoft Connect. We recommend the working distance to be about 50 centimeter to maybe up to 60, 65 centimeter. And RealSense is also good with a little bit of transparent item and a circular object like this, and cylindrical items. We believe, yeah, those items work better with Intel RealSense than Microsoft Connect. Yeah, you can see right there the camera is mounted on the arm. Okay. So in here, we also have this a tool called SmartPack. What it will do is it'll pick the cameras mounted on the stand. It will pick and whatever's inside the bin, and it will scan extra time here, and it will determine how the dimension is, and it will place to this bin accordingly. And so in this one, I believe it's using Connect for both. Connect for picking and Connect for checking the dimensions. You can see here on the next item, it's going to pick and place in the bin so that it's packed efficiently. Okay, that is it for the PowerPoint. Now I'm going to move on to showing our AccuPick interface. If you have any questions, please feel free to leave a message on the chat. Our engineers will answer them to you. So here is a okay, let me, okay, there we go. Okay, so first I'm going to explain what this flowchart does, or yeah, I'm going to introduce AccuPick to you guys. So first we would open the AccuPick software, and we will log in as an admin, and we will create a project. This is the project I created called Web Unknown VCG, and I basically used a templates that we have. It's going to use capture, recognition, filter, and display, robot script. And what capture does is it'll capture the image, and recognition will use a recognition tool that we have. So we have this unknown segment learning tool. So this will bypass any deep learning that we have to do. So this was already done by our research and development team back in our headquarters. So we have thousands of different images and different items that we pre-trained. So we can just open this and save and close. And here filter whatever in here or whatever we recognize, we will filter out any bad picks, and we will optimize the most efficient picking. So in robot script, we obviously create robot missions. So in capture block, we connect camera and robot. So for BCG, I have a 3 different TCP position. And then we calibrate within the capture block. So how let me just share the whole. Okay. Yeah. Okay. So so we calibrate through the chessboard. We can do in 2 ways. We can do it this way, which is attaching the chessboard on the end of robot arm. Or what we can do is, if you have a straight tool with the pointer, we can point out 3 different positions on the chessboard corners. We can calibrate through there. So how attached chessboard on the arm will do is we take 20 different positions, and it'll calculate based on the corners shown on the camera. And we do about 20 images. And after 20 images, it'll give us a result. It'll give us an error score, and then XYZ position errors. So for camera, as long as it falls under 0.2, we consider that success. And anything below 3 in a translation error, we consider that success as well. The rotational error usually fall between below 1, so we don't stress too much on that one. Okay, go back to AccuPick. Okay. So after the calibration is done, and we have already chosen the unknown segment tool as our learning tool. We can do a rotation. Let's say we want to have the faster cycle time. The rotation of the robot usually slows down the cycle time, so we would always force rotate to, let's say, robot arm X. Then we will always have the arm face that way, and we don't have to consider rotational time. So for VCG, visual control gripper, we choose a, so we set it here in the recognition block under TCP setting. So we would check this, and then I have a G1, which will use the 1 vacuum cup. And I have a width range here. So whatever the score fall between, Okay. So I go to display to check the images. So here, object dimension. So this is a width and height. So for three vacuum cup, we will be using that with the biggest object. We can pick this one with the one vacuum cup. You can see it's only 63 by 44. So we will make sure that in our multiple TCP with the gripper one, which only uses one vacuum cup, we make sure that it falls between 0 and 100. And vacuum cup 2, I have it like this, but the difference between the cylinder object and the box was the height. So the height was only 34 on this one, and height for this one is 162. So I make sure to have the gripper 2, which uses 2 vacuum cup. Make sure it doesn't exceed 150. So on G3, which uses all 3 vacuum cups, since with 3 vacuum cups, it should be able to pick the most, the biggest item in the bin. I can do 100 to the biggest object in the bin. So I have a if else right after the filters, which is just checking if the item is present in the bin. And this if else is so if there is item inside the bin, then I would check to see if it's going to use gripper 1. If it is treating gripper 1, I have here that I'm going to have a IO pop out. So one tool will pop out. Yeah, so that will pop out. And it'll run picking mission here. And if I have a 2, so if it's not gripper 1, it'll use gripper 2. It's going to check if it's going to use gripper 2, which will use 2 vacuum. And I will check to see here. So it's going to use 2 vacuum cups there. And if it's not using gripper 2, I'm checking to see if it's using gripper 3. And I use all 3 vacuums. So in each robot script here, G1, G2, G3 robot script, it's going to run. Also, basic of our robot missions is going to run a start pick and start drop in. What this will do is in start pick we create missions so that it goes over the arm, or we make sure the arm goes over to the bin, and we go to pre-target position, which is about 50 millimeters above the target, and we move directly in perpendicular to the item, and I turn on the IO, and then I wait for a split second to make sure that it grips properly, and I have a go back up to pre-target position, and this will be positioned on top of the bin. And this is the last position, the start pick, which would just be outside the field of view. I also can have this checked so that our cycle time could be faster. what this will do is it will try to um, scan while we're doing a drop mission. So drop mission is simply move to this position, and then we're going to turn off the vacuum cups, and then it's going to just come back up. I also have set a basic collision avoidance. So I have set a just by creating just checking the cylinder tool, and I measured how big our gripper was, and then both radius and length. And if I say have a show tool, you can see how the pick or how the arm is going to go in for the pick. And I also have this bin config, which we input a bin information. And then you can see in 3D how the bin looks like. So if we have created bin config, and we have checked collision avoidance, and we set these parameters, then it's pretty much going to eliminate if there is a possible of collision. Okay, I will place more items inside the bin. To show. Okay. So it's using 3-finger. So basically, whatever is the highest inside the bin will be the priority pick. So there, you can see here, it was a 2-finger. Now it's going for the 1, smaller. Missed the pick there. We can also have a digital in setup so that we can check whether the pressure is there. That way we know if it's picked or not, and we don't have to go for the same pick. So that's pretty much the basic idea of how we create a robot mission or create a project within AccuPick. So if you're interested in machine learning, this is pretty much the same idea, except that we would actually create a learning tool here, and we take images of the item, and then we would go through the deep learning. Has trouble picking this item. Okay. So at this time, uh, if you have any interest in SmartPack, uh, you can feel free to contact us about it. If you also have interested interest in our different products, feel free to contact us for more information. Yeah, as I mentioned earlier, I believe intelligence works a little bit better for symmetrical items. I think I have the wrong uh, tool sticking out. Okay, so at this time, we can take it, it did a collision with the bin. I think I didn't set the tool properly. I didn't account for the tubes there. Okay. So I can take any questions you guys have about the gripper or software or other products we have. So if you also have like a ongoing project uh, that you may want us to take a look, or we can do that as well. I also have to delete some point cloud so that it's not trying to pick the bin up. Okay, seems like that's it for the questions. So this is it for the presentation for our AccuPick unknown with vision control gripper. Thank you everybody for joining. I hope you guys have a wonderful day. We'll be stopping the presentation shortly.